In this presentation, we are going to look at inference procedures, and in particular, what we're looking at is the different mean lifetimes of two different types of batteries. So we got two populations, which is two batteries, two sets brands of batteries, and we're interested in the lifetime of each, comparing the lifetime of each brands. And what we're going to do is take a sample of 100 from both types and measure the working lifetimes. So we have two sets of summary statistics here. Okay, type 1, which has both samples are sample size 100. And essentially, type 1 it has 25 hours mean life with a standard deviation of 4 hours. And then type 2 has 23 hours with a standard deviation of 3 hours. They're not particularly long lives, but let's just say it's a special type of battery, okay? Or maybe a rechargeable or something like that. Now, I'm focusing on the hypothesis testing part of this, but I'm just going to set up the confidence interval part, but not go into it in great detail. I'll sort of save that for a different presentation. So really, the hypothesis test is the main part of this presentation. Just as a quick remark, we're going to use a 5% significance level. Now, so what I'm going to do here is use this hypothesis testing approach that is sort of designed for examinations where you would use critical values, which is quite common still, even though other ways of doing things are becoming more common. What you would have is statistical tables and probably a formula sheet as well. Okay, so if you want to take a quick pause of that video there, and just have a quick read of that if you want, we'll proceed from there. So the following step, the first step is to specify the null and alternative hypothesis. So the null hypothesis proposes no difference in lifetimes, battery lifetimes, okay? Just a sentence like that. Okay, that's just a sentence like that there, just to sort of make a statement about that. And then you could do, right, also the alternative. The alternative proposes that there is a difference. Oh, there is a difference in battery lifetimes. Now that's actually the question we're being asked. We're not asked if one is has a longer lifespan compared to the other, and like that. We're just actually, are they the same or are they different? Okay. Now, so population means are equal to each other. They're not equal to each other. That's how we would state that mathematically. Here, mu is the mean lifetime, mean battery lifetime. Okay, for both batteries. Okay. Now, also what you can do is specify it in terms of the difference between groups. So it's equal to 0 or not equal to 0. Okay. So equal to 0, not equal to 0. Okay. So here what we're doing here is looking at in terms of the difference between the two means. So it's the difference in means. And this emphasizes the expected value under the null hypothesis, the expected value of the difference in means under the null hypothesis, which is 0. So that's sort of helpful to look at things like that. So just as a quick remark, it's a two-tailed test. And also we're using a 5% significance level. Well, how is it? How do we know it's a two-tailed test? Well, it has this sort of structure here: equal to versus not equal to. And not equal to is actually equivalent to saying greater than or less than or greater than. Okay, it's almost as if to say how many alternatives to the null hypothesis does the alternative hypothesis offer you. Okay, so that's that part there. Now you can go into a bit more detail here. I'm just trying to get through this very quickly because I realize that hypothesis test questions take up a good bit of time. So what we have to do here is now set up the standard, the test statistic, and the main part of the test statistic is calculating the standard error. It's a big sort of calculation regarding the test statistic. So this is our standard error formula here. It's the variance of one group divided by the sample size plus the variance of the other group divided by that sample size. So S1 and S2, there we go. And essentially what we have there is just, we both know that the sample sizes are 100 in both cases. 4 is the sample size for the first case, 3 is the sample size for the second case. This actually is it 4 and 3, or is it 3 and 4? Sorry, I just double checked that. Yeah, it's 4 and 3. Not that it matters too much, but just I have to have them associated with the right sample size, so it's just a good habit to get into. 4 squared plus 3 squared is 16 plus 9 divided by 100. That is 25 plus divided by 100 is 0.25. The square root of 0.25 is 0.50. Okay? So moving on. Now this is the general structure of the test statistic, and you could make some sort of statement that the test statistic is a normally distributed random variable with mean 0 and variance 1 squared. It's a Z distribution essentially, standard normal distribution. Just a sort of, just don't put in TS out of the blue. Just explain what it is. Okay, just a little exclamation. Now this is the general structure of a test statistic here. It's the point estimate, which is the difference in sample means in this case, minus the expected parameter value of the null hypothesis. So we expect no difference of the null hypothesis, which is 0. So the difference in means is 25 minus 23. That's our point estimate there. That's x bar 1 minus x bar 2. And that gives us 2. On the null hypothesis, we expect a difference of 0, and the standard error is 0.50. So essentially our test statistic there is 4. Okay? Now, so moving on, we'll talk about the critical value. Now, I'm not going to spend too much time on critical values. Just suffice to say that we have a large aggregate sample size, that it's a two-tail procedure, we have a significance level of 5%. So hopefully at this stage you'll be familiar with that enough to sort of realize very quickly that the critical value there is 1.96. 1.96 is like a threshold that the test must cross in terms of strength of evidence, where the test statistic is a measure of that strength. So working in reverse, the test statistic is a measure of the strength of the evidence, and the critical value is a threshold that must cross, the test statistic must cross, in order for it to for us to say that the evidence is sufficiently strong. So we either reject the null hypothesis or we fail to reject the null hypothesis. Okay, so what is this based on? This is the absolute value of the test statistic will probably help there. If it's greater than the critical value, we reject the null hypothesis. If not, we fail to reject the null hypothesis. Now here, clearly, the test statistic is 4.00. The critical value is 1.96. Obviously, that is the case here. So we reject the null hypothesis. There is clearly a difference in means. One battery is better. The mean battery lives are different to each other. Obviously, one is better. We're not saying which, but they're not the same. Okay, so there is a significant difference in terms of average battery life. A quick conclusion like that actually is just a statement there. A significant difference in terms of battery lives. Just actually include something like that there. Because quite often you're actually asked for a conclusion. So just add in some more there, but it's sort of a statement, a sentence about the conclusion, about what your conclusion is. That's important there because you're often asked for it, and often people forget to put that in. Okay, that's good. Leave it there.